So these are the 3001 SEs. These are actually the matching primes that I got imported from Japan that were actually, they have a serial number that are matched with a special marker that actually marked them as being a left and a right, which is pretty damn rad because they're basically meant to be prototypes for lab use and I own them, so that's pretty cool. But the way they engineered these was to make them as over-engineered as possible, to the point where the freaking binding posts were custom made out of solid metal and then powder coated with silver. And then it came with, rather than just ornamental clips, it came with little plugs like this that you could use so that you never have to actually twist the binding plug. Even though they're 5-way binding ports or 5-way binding plugs, you could actually just stick wire through there and just lock them in using this thing. So you literally never have to twist them. Or you could just, if they're thick enough, fold it and then just stick it right through. Or they support banana plugs, or just twist them as you typically would a normal twisting 5-way binding post. So the form factor looks familiar. It has this crescent shape to it right here. And that's because this was actually used as a way of modeling the blade. In fact, what's interesting about it is that if you look at the shape of the tweeter, you look at the shape of the tweeter there, you'll notice that this tweeter is actually much flatter. This tweeter is actually, if you look at it in terms of its angle, it's like you cut it from something the shape of an orange versus something the shape of a ping pong ball. Whereas also, if you look at the actual depth, the depth of this matches that of the blade, whereas this is larger, but it's a lot flatter. When they designed this speaker, I added this because I was kind of just testing out the way this driver works. I'm gonna take it off in a few days. But when they first designed this speaker, it was meant to actually work as a intermediary between the XQ and IQ series, or the classic Uniq style, and the new avant-garde style, which is where this comes into play. The receded surrounds, the flare, and then the outside of the driver itself being acoustic elements. But we're talking about stands and damping. And what's cool about it is, as far as being over-engineered, not only is like the whole entire thing just really over, these are also the only ones that still play up to 55 kilohertz plus and minus 3 dB. And the blade goes up to 48, I believe, whereas the LS50s go up to, I think, 38. So they still use these for prototypes, and they just recently used them to make the T1 Slimline Ultra Slim woofer. And I recognize the radio fins. That line right there is actually where the voice coil is. It's also the only speaker that has the same wide set voice coil as the blade. And the way that this whole entire waveguide here works, it allows the dispersion, just like if I were to fill this thing up with water and I threw a stone right into the center, the water would actually spray a lot more rapidly with more force sideways than up and down, right? Because the way it's designed is that it's meant to actually minimize the amount of ceiling and floor reflections, because that's not what we want, and maximize the amount of lateral dispersion, because that's what we do want, because these are meant to be facing forward and along with its twin. What's cool is, check this out. So these are lab prototypes. Look at how exactly matched they are. Check out the waveguide. You'll notice that they could have made them perfect, but they didn't make them exactly perfect. So look at them now, and that's his twin. So yeah, so we're talking about basically how these things are exactly mirrored, but also that their variation is so tight that they actually needed to be known to be one is left and one is right, which is like weird, because these right here are actually, you know, the limited edition black ones, and they actually have matching serial numbers as well, but it doesn't matter which is left and which is right. They just made them symmetrical. So there's actually no way to tell which one's the left one, the right one is, because there's no reason why you would be able to tell. But with these, they actually made it so that you could tell. And they made them perfectly mirrored. And it was so deliberate that I could actually take this driver, flip it 180, and it would look identical to the other speaker. But being as they're supposed to be mirrored, they end up actually they flipped it 180 to make it so that it would actually be one way is this way and the other one's this way. So yeah, so we're talking about dampening stands. Something else they did that was really cool was this is when they first started working with the idea of using a lot of golden ratios actually around the XQ and IQ and 207. So this right here is an ellipse. This ellipse right here, if I were to draw a square around it, would actually be a golden rectangle. And one of the ways you can know that that's kind of interesting is, oh, first of all, this is also the subwoofer that came with it. And it's the only subwoofer that I know of that exists that has a single active driver, a ABR on one side as a passive radiator, and another passive radiator on the other side, and yet I could actually set a coin on its edge on top and it never even moves and nothing rattles. So this thing happens to just dampen itself so perfectly that it just freezes time around it for some reason. So that's pretty neat. And as far as the way they made the stands, is something that was also very well thought out, and I'm surprised that they didn't continue making it this way. You notice that the stands are not actually just elliptical, they're not just round, they have this distinctive cutout. And the reason why is because they're actually designed to bite in. This thing doesn't really need it so much, but you know, if you were to want to position it perfectly in a room and then you were to accidentally bump it, it would fall right back into the same position, because these spikes right here would grip into whatever it was leaning into. It would always be on axis, and then it would just fall back on. It's just like with this. Typically when they make round stands, they're really helpful because you could churn them, right? You could like redirect the speaker in any way you want, because angling speakers matters. But with these, they cut a V on the back, and just like the way this thing right here is almost like a blade, it's meant to be stronger forward and than it is side to side, because obviously, you know, a speaker pistons forward and backward, and that's what, you know, bass is gonna cause a thing to want to wobble forward and backward, right? But if this thing were to want to wobble, it could only wobble in one direction, because that tilt, when I'm tilting it backward, it locks into that triangular formation. So this thing is actually a tripod. This guy's like a disc. So I can still churn it and rotate it and face it, but wherever I decide to face it, if I accidentally knock it in any direction, it'll actually just end up falling back to where I had to face to begin with. That's how precise they had these things made. And I don't know why they didn't continue doing it that way. The stands they continued making afterward, they started making these round stands again, instead of making like these elliptical ones, when an ellipse is like the best shape, you know, it's like, and not only does it cancel out its own resonance, but this round shape has the benefit of being round, which means that I could churn it in any direction I want without it bumping into things, and it doesn't have the ability to fall off axis, which means I can even, like, you know, clean underneath it if I wanted to. So when if something were to happen, like an earthquake were to happen or something like that, it would just rock forward and backward, and it would just stay exactly locked on axis like that, which is pretty rad. So yeah, so these are the first ones to actually start using the flare, where it cuts off, and you can see this little raised edge right here, along with this horn, flows all the way and strikes this right here, which would be the shadow flare, and then it ends up basically using the rest of the baffle itself as an acoustic element, which is something that wasn't really done before. It was done for the C series that wasn't a Unicue, but it wasn't done for any of the regular Unicues because the surround was in the way. So that's why they got rid of the surround. Once they got these up to playing 55 kilohertz, they got rid of the little bobble on top. You remember that if you look back at the 207 reference series, there's that coin again. The 207 reference series, it had a little bobble on top, which was a hybrid tweeter that allowed it to play up to 55 kilohertz. The XQ series also had the bobble on top that had the ability to play up to 55 kilohertz. Oddly enough, the XQ series doesn't exist in the museum page, but these do. So I don't know why that is, but these are the last speakers that play up to 55 kilohertz. And I mean, that makes sense as far as prototypes, and they're also the only ones that are listed twice in the Unicue Tech Museum as the 7th and the 8th generation. And I find that kind of odd because, again, I think the XQ should probably be the 7th generation, because it doesn't really make sense to me that one speaker be 2 generations. It kind of makes this like the Jesus of speakers or something. But yeah, I don't know why that is, but I think maybe it has to do with just like how many variations that actually did occur when they were making this speaker. Because like the ones that they actually ended up with were just so much better than the ones they started off with. So this right here was actually made to be as conservative a design as possible. And the way they did that was by making it so that the baffle was completely out of the way. It was following all the basic tenets of the way that you would typically design a mono speaker if you were to design a mono speaker. If you were an astronaut floating around in space and you had a speaker following you around, like, you know, helping you, you want a speaker that was something like this, where it could float around, it could rotate, you could rotate, and it would always be, you know, it would always sound the same to you, right? Different angles, it always sound about the same to you. Whereas this speaker breaks those rules on purpose. This is convex. The baffle is actually out of the way. This thing actually has a baffle that is deliberately in the way, so that the driver actually uses elements outside of the driver itself to augment the sound of the whole entire speaker. And if you were here, what's interesting is that these things actually sound bigger than these things, and you can probably hear it. I'm gonna go and switch. So these are the 3001 SEs, and these are the LS50s. Like I can hear like the texture of the organ way better on the little guys than on the LS50s. Because whereas these actually excel more at the old-fashioned vintage sound, which they are very, very good at, they don't excel as much at holography or like just 3D spacious, like, you know, like omnidirectional sound. Whereas these are actually designed specifically to sound as holographic as possible by using every single element about it to be an acoustic element. While this thing is the only acoustic element, and the box only serves to be volume for the rear port to add the 52 hertz boost. Oddly enough, this thing also has a 52 hertz boost. It does that through a technology that someone else tried to patent 4 years later called Vienna, and I'm not going to tell you the name of the rest of the thing, I don't want to talk trash about anybody, but it has a special type of driver that only this and the Blade has, and that's how it's able to actually have a voice coil. And it was the first to have the first, like, the oversized 2-inch voice coil, but that's how it's able to have the voice coil fixed at the 1/3 mark. You can actually feel it. It's right here. Whereas all voice coils are typically right in the middle, right on the inner rim. The voice coil on this thing's right here, which allows for the distortion levels to be as low as the Blade, which is why it became the basis for the Blade. And the way that it works is that it actually uses diffraction deliberately. So they designed it basically outward in. Once they actually got rid of that hyper tweeter on top and made it so that the tweeter in the middle could play all the way up to 55 kilohertz, they maximized the hell out of it using computer modeling to make sure that the tweeter could be as even as possible. So this array in front is actually, it's called the Tangerine Array waveguide, but I'm tired of using the word waveguide because everything's a waveguide, so I'm going to call it the Tangerine Radiator. The Tangerine Radiator is meant to make it so that sound pressure is equal across the entire dome, even though the dome moves forward and backward, which means that now that instead of the dome just grazing the air on the side and being, you know, just more shy on the side and not very reliable, and then having more of like a hot spot in the center, the waveguide, or the radiator, I insist on calling it, is meant to make it so that air is able to sprawl on the XY axis as reliably as forward and backward. That means that they were able to maximize the aerodynamics and the acoustics of the entire baffle itself on the XY axis, which is actually, interestingly, the first thing that happens before anything else happens. So sound sprawls outward across the baffle. So it comes out from the tweeter, comes out of this flare right here. It actually ripples across this little ridge, bounces off against the shadow flare here, then continues along the waveguide. The waveguide is actually more extended here than it is here. So that basically the dispersion pattern of this thing is almost as if it's sideways. It actually disperses sound more widely than it does vertically. So what's interesting about that is this right here is a subwoofer that came with it, and the subwoofer that came with it actually had an active driver in the center, a passive radiator in front, passive radiator in the back, and they actually merged the active driver in the middle and the passive radiator in front, and that's how they're able to solve the problem with the Blade, with having 4 low frequency drivers so tightly up against each other. Because as you can see, like, this thing right here is as wide as this thing is deep. So the Blade is the same thing, except for with 4 low frequency drivers, right? When you have 4 low frequency drivers, even shooting at a back wall, you're going to get a lot of ring distortion. because the back waves are gonna, strike at a perpendicular angle and then go back forward. So they're gonna have that delayed echo, just force its way back up and strike the cone again. These are flat, and that would be the most susceptible to that, except for the fact that they realized that by adding a flat diaphragm and a cone and then venting it, you create an air pocket and then tune the air pocket to make sure that only the frequencies that are sympathetic that you want that's coming from the cone would actually come out of the actual diaphragm that's facing outward, while anything that happens from the other side stays on the other side. It shields it from the behind. And so basically they took this model, they merged it, whereas in this one, this radiator has the outward surround, and the cone actually has its own surround that's facing inward. New ones actually don't have two surrounds because they don't need to, because they're merged, right? So if you look at the new surrounds on like even the KC62s, they all have that cone and then a flat long throw diaphragm in front, and that's the point, is that it's meant to actually shield its own rear waves. And this thing actually still exists. It's called the T2 Slimline sub, and it is now it's a larger box. It's an MDF box, and I guess you're supposed to put it up against the wall to make up for the lack of the rear low frequency radiator. But yeah, this thing actually worked well enough that it ends up dampening itself so well that you could just blast bass on this thing and the coin just kind of just stays put. So yeah, did a masterful job at that thing. So everything about the 3000 series ended up trickling forward and ended up redefining every single thing about the way KEF does its drivers, interestingly. So this would be the most conservative change, interestingly, because this flare right here and then this Z-flex is actually the end of the flare. This thing is meant to be a flat portion. This horn is meant to be aimed at this portion so that the tweeter and the woofer would, no matter what, at some point merge so that the sound of the tweeter and the woofer would always sound like it's coming from either somewhere within the driver or at least here. Whereas before that, it was all timing based because they had the roll surround. I'll show you. This is an XQ40 style. I guess it's a mid and a tweeter with a tangent waveguide, because they couldn't actually use low frequency. You couldn't use a low frequency woofer, and that's why they couldn't make like the XQ series. They couldn't actually make them play like they couldn't do what the LS50 was. They couldn't add a woofer and then have it just kind of go as wild as possible, because this thing still had a rubber surround, which means that the tweeter, even though it does have the radiator, so it has the ability to have very equal pressure along the sides, you still see this little flare right here, but then you also see, this is an optical illusion, you see a flat portion right here. This flat rim right here is actually meant to give it time, so that when sound is coming from the tweeter, it has enough time in here to merge with the woofer on phase, so that they both blend and interlace and fire forward at you. And so no matter what, it sounds like one sound source especially when you're far away. And just as a quick side note, with all KEFs, you're never supposed to listen to it this way. You're actually always supposed to listen to it this way. And the way you test for that is you stand in front and you'll hear the tweeter, and that's how you know you're listening to it wrong. You go like this a little bit, and you actually hear the sound of the tweeter migrate to here. And that's actually where the sweet spot is. This thing had an outer rim and then a flare, and this outer rim is now gone. What they did was they made the tweeter 1/3 bigger They made the Tangerine radiator 1/3 bigger, and they also made the flare 1/3 bigger to the point where it's the whole entire driver. And then they added the flat surround that they call the Z Flex now. And the Z Flex has the advantage of working like the outside of the woofer, but at the same time, since the outside of it, since it's flat, it's hinged, so it's stationary, which means that the tweeter will never ever miss it. Whereas in this one, if it actually drags along the surface and it's basically too high, it's going at too high frequency, then it's going to end up gutter balling and hitting the surround, right? So on the LS50s, there's basically 100% accuracy rate. Because the outside of the Z Flex is actually stationary, anything coming from the tweeter along the outside will always strike the Z Flex. And since the Z Flex is actually the outside of the woofer, it'll always end up being merged on axis and interlaced with the woofer and sound like it's one single sound source coming at you. So that's really what defines what predated the 3000. See the 3000 right here? It's just a flare. And this right here basically emulates this flat portion right here. It no longer has that flat portion. It doesn't need that because anything that's coming from here will always end up hitting this thing. And then this thing will end up sprawling forward at you, so that the woofer is playing, it could woof as much as it wants. It will never get in the way of the tweeter, and the tweeter will always end up sounding like it's coming from the center and from the outside at the same time. So then it ends up sounding like a single point source. And with the aid of the surround around the outside of it, it ends up actually sounding bigger than it really is, which gives it that extended holography that makes KEF what KEF is right now. And that's why the Blade has a smaller Uniq, a smaller driver, as you've noticed, but it sounds bigger. It's not because the Blade itself is bigger. That doesn't make any sense, right? It's actually because of the pod, and the pod has a waveguide, and that waveguide is what you're seeing in front of you. It's a very specific waveguide. It has a contour that's a crescent shape, and it's designed to make it so that the waves are dispersed in a way that is more than what the driver itself is capable of, which is what allows it to sound bigger than just the driver itself. Just a little cool little little factoid there. And yeah, so this is my second set of stands right here. So yeah, see, you can just keep doing this, and it just always kind of just stays on axis, which is kind of dark. Sorry about that. But yeah, so anyway, yeah, so that's pretty much this last of the classic Uniq, and it played up to 55 kilohertz. And then this is the first of the modern Uniq, plays up to 55 kilohertz. And no other modern Uniqs actually play up to 55 kilohertz. And the reason why is because this is still used as a prototype to this day. And you can see why. It's actually like pretty amazing what it's capable of doing. Especially one of the drawbacks behind it is that due to the fact that it comes with feet and it looks kind of like the egg, and that's the egg right there. The eggs are based off the Celestion AVPs. If you look up the Celestion AVPs, you'll know what I'm talking about. These right here are based off of pretty much taking off the heads of the 207s and then optimizing them. So they made them taller to give them more volume, and the taller shape is more elliptical. And again, it's that cool little golden the golden rectangle thing going on. Literally, if I took this shape right here, it's pretty much the same exact shape as this shape right here. They just really love that shape, which is the same shape as the inside of the port, because it's also the same shape or the same ratio as this is to this is to that is. And that is called phi. And that phi, that number is just known in nature as being the least obstructive number there is, and allows for a lot of really cool features that I'll link. And it makes it so that KEF could kind of cheat in a way, where they could actually get it both ways. They could actually get it so that they'll get pretty cool on-axis measurements, but in real use, the speaker actually sounds much different than what the actual marketing on-axis measurements would tell you, which is really clever of them, because they have if KEF wanted to make a flat speaker, they would just push a button. They've been using computer science to make speakers since the start. They're like the pioneers of that. They're like the Pixar of making computers, using computers to make like finite element analysis to make speakers. But anyway, yeah, so there's my little short tour of the history of the evolution of old KEF to new KEF. Thanks.